Hey students, we're going to go over the atoms and moles in this video. Okay, so first off, the mole, you don't have to write this information down, but the mole is a counting unit. Okay, you already use counting units, you might not even realize it. You know, for example, how much is in a pair? 2. It doesn't matter if you have a pair of earrings or a pair of shoes or a pair of flowers, it's always going to be 2. 2 earrings, 2 shoes, 2 flowers. You know how much is in a dozen. You know that it's going to be 12. It doesn't matter if we have a dozen donuts, a dozen eggs, or a dozen basketballs. We have 12 donuts, we have 12 eggs, we have 12 basketballs. And a mole is the same thing. A mole is going to be a measure of how much stuff we have. And the problem, or not really the problem per se, but the thing about the mole is that it's just a number that you have never heard of and seen before. A pair and a dozen, those are familiar units to us, it's a familiar number, but a mole is 6.02 times 10 to the 23 particles. This is what we need to know. 1.02, or 1 mole is equal to 6.02 times 10 to the 23 particles. This is what we call Avogadro's number. It says representative particles here. The reason why we say representative particles is because it doesn't matter what we're talking about. A mole is a mole is a mole. And if I say a mole, that means it has 6.02 times 10 to the 23 particles. Okay? In this case, we're going to be talking about atoms and elements like sulfur or iron or copper. So we have a mole of sulfur has 6.02 times 10 to the 23 atoms of sulfur. A mole of iron has 6.02 times 10 to the 23 atoms of iron. All right. The next slide, you don't have to know, you don't have to write down, it's just to give you an idea of how much stuff is actually in a mole. But the thing is that the atoms are so small that in order to get a quantity that we can work with, we need to have a large amount of it. We have to have a lot of those things, 6.02 times 10 to the 23 to be specific. So, this slide is again just talking about what I was saying before. The representative particle that we're going to be using in this particular unit is the atom, because we're talking about elements. This is going to change. We are going to be talking about the mole again in future units, and this will change with each of those units. We'll talk about that when we get to it. So we're going to solve problems with Avogadro's number using dimensional analysis. Now, dimensional analysis is a tool that allows us to convert from one unit to another unit. And I bet you all can already do dimensional analysis and you don't even know it. For example, if I were to ask you how many inches were in 2 feet, what would you say? 24. If I were to ask you how many feet were equal to 36 inches, what would you say? Right, 3. We already know how to do that. That's actually dimensional analysis. So we knew that when we had 2 feet, and I was asking how many inches, we knew that we were going to have to multiply that by 12, because we know that there's 12 inches in 1 foot. Conversely, when I asked about the 36 inches, you knew that you were going to have to divide by the inches, because you know that 12 inches are in 1 foot. So we already knew that information, and we were able to do that without even thinking about it. We just have to think about it a little bit more with the mole because it's stuff that we've never talked about before. We're able to do this because this right here is called what we say a conversion factor. And a conversion factor is basically like multiplying by 1 because 1 foot is equal to 12 inches. This is an equivalency. All right? So these problems are on page, I think it's 9 in your packet. So I'm going to show you how to set up these problems, and I'm going to show you how to use your calculator. So when it says how many moles are in 1.20 times 10 to the 25 atoms of phosphorus, you always start by writing what was given to you. 1.20 times 10 to the 25 atoms of P. Now I'm going to have you guys write the unit and the symbol because it's really important to keep track of your units when you're using dimensional analysis. And there's going to become a time where we actually are changing units and changing the substance in the same problem. So we want to keep track of everything. So when you set up your conversion factor, whatever unit you're trying to get rid of, that unit has to go at the bottom of your conversion factor. So we have to put atoms of P down here. Now the number that goes with atoms is always going to be 6.02 times 10 to the 23. That number is always going to go with atoms right now, nothing else. And we know that 6.02 times 10 to the 23 atoms of P is equal to 1 mole of P. So we can stop setting up our problem because we have moles of P up here and we're looking for moles in our answer. So let me show you how to input this into the calculator. We want to make sure that there's no funny business in your calculator. Let me just clear this out. So this is what I want you to do, 1.2, so you type in the first part of that number. Now to get to that times 10 to the, we don't use the times 10 caret, nothing like that. That's going to actually mess up your answer if you don't input it incorrectly. So I'm going to show you a trick that will get you the right answer every time. You're going to push the second button up here, and then you see this EE right above the comma? We're going to put that. So you can see that it says 1.20E right here in the calculator. That E means times 10 to the. And then you just put your exponent, which was 25. Notice I do not put this up in the air. Everything is in line with itself. Then I'm going to put divided by. I'm going to do the same thing, 6.02. I'm going to push my second button, push my EE, use the exponent. That EE means times 10 to the. And then I'm going to push enter. Okay? Now, when you're trying to do your Sig Figs for this, the Sig Figs are always based off of your starting value. I always encourage you to actually write that 0 down because a lot of times students will look at their work for Sig Figs instead of the problem itself. So, 1.20 has 3 Sig Figs, so we want 3 Sig Figs for our answer. We should get 19.9, and don't forget your unit, moles of P. Alright? Then let's look at this next question. How many atoms are in 0.750 moles of zinc? So again, always start by writing what was given. 0.750 moles of zinc. We're going to use a conversion factor. Remember, whatever unit you're starting with, that unit is going to go down here at the bottom. So we put moles of zinc down here. The number that goes with mole is always going to be 1. 1 mole of zinc. We know that 1 mole of zinc is equal to 6.02 times 10 to the 23 atoms of zinc. We know that we're done setting up our problem when the unit that we want for our answer is up at the top of our conversion factor. So we can go ahead and plug this into the calculator. So 0.750 times, because it's in the top, our Avogadro's number is in the top, 6.02, second E, 23. And we're going to have 3 Sig Figs for our answer. So we're going to record our answer as 4.52 times 10 to the 23 atoms of zinc. Now look here. Look at your answer in the calculator. You see this E here in the answer? That E again means times 10 to the. That's why I put times 10 and raised my exponent. The number behind the E is the exponent. Always check your answer to see if there's an E in your answer because a lot of times students will neglect to see that part and finish writing out their answer. Okay? Our next video will go over the mass and the mole.